Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to talk about 10 hardest GMAT data sufficiency questions. So let's go ahead and get started. So you can pause this video and try this question out by yourself, and then I'm going to provide you the solution and the answer. So this question here, it says that A, B, C are integers. So you got A, B, and C, which are integers. The question is telling you that B is greater than A, so that is something that we know. And the question is asking us, is B plus C greater than A? So it's basically a yes-no data sufficiency problem. Okay, so what does the first statement tell us? So the first statement tells us that C is greater than A, so that's what it tells us. And we already know that B plus C is actually greater than, we already know that B is greater than A, So we know that B is greater than A. So what we can do is we can actually add both of these inequalities here. So B plus C is going to be B plus C here is greater than, because the sign is the same, so we can keep the same sign. A plus A is 2A. So the question is telling us B plus C is greater than 2A. Is B plus C greater than A? Well, the answer is yes and no. Why? Because if these are positive numbers, so for instance, you can have B to be 2 and C to be 2 and A to be 1, then B plus C is going to be 4, which is going to be greater than 2A, which is 2. So in that case, is B plus C greater than A? Yes, it is, right? Because it's greater than 2A, so it's also greater than A. But what about negative numbers here? So you can have negative numbers. So for instance, you can have B to be as negative 2 and C to be as negative 2. Then you have to make this to be greater than 2A, so you can have A to be negative 3. So if you keep that, so B is negative 2, C is negative 2, and A is negative 3. Is B plus C greater than 2A? Well, yes, because negative 4 is greater than negative 6. Is B plus C greater than A? Well, no, because B plus C is negative 4, which is not greater than negative 3. So I'm able to satisfy this particular condition here and here, but this particular condition is giving me a yes here and a no here, so that means this statement is insufficient. So that solves it. So now let's move on to the second statement. The second statement says that ABC is actually greater than 0. So that doesn't give me too much information, but I'm still gonna disprove it. So for instance, I can just pick up these numbers where A is 2, B is 2, and C is 2. So if I pick these, C is 1. If I pick these numbers up, then ABC is greater than 0. Then is B plus C greater than A? Yes, it is. But as soon as I make them negative numbers, or I turn to negative numbers, so then I can make B and C both negative. So make this negative 2, make this negative 1, and keep A as just 2. So that will make ABC greater than 0. But is B plus C greater than A? No, not. So that gives me again a yes and a no. That means this is also insufficient. Now let's combine both the statements. Now I hope you're understanding how am I choosing these numbers. I'm not just choosing these numbers at random. I am choosing them, so that I have very low cognitive stress, and I'm choosing simple numbers. I'm using the cases which have already been used. So if I've already used this case here, why not just use the same case here, so that you don't waste a lot of time and cognitive resources. Now let's combine both the statements. So if we combine both the statements, you've got C is greater than A. So that's one thing that you got. And you've got A, B, C to be greater than 0, right? So you got C greater than A, and you got A, B, C greater than 0. And you have to prove that is B plus C greater than A. Now how do you do that? So whenever you are combining statements, I would recommend using algebra. I would not recommend using numbers, because then you've got so many convoluted you've got so many convoluted statements coming. So just use algebra if you can, because if you start using numbers, you're going to get confused. And another information that we already know from the question stem is that b is greater than a. Now we've already combined these two statements, and we know that b plus c, while combining these two statements, is actually greater than 2a. And I'm just going to write 2a as a plus a. Now ABC being greater than 0 actually takes this particular case out, because that in this particular case ABC is not greater than 0, which means that at least two of them, either all of them have positive signs. So if all of them have positive signs, then if b plus c is greater than 2a, then b plus c is greater than a, is going to be greater than a. So that's going to give me a yes if all are positive. Or two of them can be negative and one can be positive. So that's another scenario. So if two of them can be negative and the other can be positive, so if, for instance, let's suppose if B and C are negative. So if B and C are negative and A is positive, then it will violate this particular condition here, right? Because then negative can't be greater than positive. So that's not possible, right? So which means that if B and C can't be negative, that means A has to be negative, and either of B and C has to be negative. So let me just rephrase that, what I just did here. So what I did here is that I just picked up this particular statement from here, which is we're combining both the statements. So that's what we got. And we have this statement here. So in this particular statement, ABC is greater than 0, which means either of them, either all of them have to be positive. So if all of them are positive, which means statement 2 is satisfied, which means b plus c is greater than 2a, that means yes, b plus c is greater than a. If you're greater than the twice of a number, positive number, then you're greater than that number. So then that would actually give me a yes here. But what if a is negative and b and c are positive? Well, that will also satisfy this, and that will also satisfy this, so that will also give me a yes. What if B and C are negative and A is positive? Then that's not possible, because B and C can't be negative, because a negative number cannot be greater than a positive number. So that's just not feasible option. So which means that I'm going to get yes all the time. So if I'm going to get yes all the time, that means combining both the statements, I get my answer. So my answer is option C. So it was not a difficult question from the sense of being tricky. It was a difficult question because it required some organization, and a lot of pieces of information were moving, and you had to put those pieces of information together to get the answer. So I hope this was helpful, this particular question. So now we're going to move on to the next question here. Okay, so this question here says absolute of x is equal to absolute of 2y. So what does this question stem tell me? Again, you can pause this video and try this question out by yourself. So absolute of x is actually equal to absolute of 2y. So that tells me that either x is equal to 2y, or negative x is equal to negative 2y, or x is equal to negative 2y, or negative x is equal to 2y. So I get all the possibilities, right, that can arise out of this. And the question is asking me, what is the value of x minus 2y? Well, I can get the value of x minus 2y from this stem and from this stem, because in both the stems, if I calculate for x minus 2y, that will actually turn out to be 0, right? Because this will also give me this, and this will also give me this. But these two stems won't give me that, because from these two stems, the only thing I know that x plus 2y is actually equal to 0. I don't know anything about x minus 2y. So let's see what the question stems tell me. So first statement says x plus 2y is equal to 6. Well, if x plus 2y is equal to 6, that means this here is not possible. That means the only thing possible is these two stems, and I know from these two stems that x minus 2y is actually equal to 0. So this actually gives me a definitive answer. So this statement is sufficient. Let's move on to the second statement. The second statement says x into y is greater than 0. Now remember guys, whenever you see x into y is greater than 0, the question maker is just implying one thing, that they either carry positive signs or both of them carry negative signs. It's not possible for x and y to carry opposite signs. So if they either carry positive signs or they either carry negative signs, that means that only these two stems are possible. That means they cannot have opposite signs of each other. This is just not possible again. So that means, again, x minus 2y is actually going to be equal to 0 here. So this is also sufficient, which means D is my answer, that both the statements are sufficient. So I hope this was helpful, guys. Again, this question required some sort of organization, solving out the question stem, and then moving on to the question statements and using the information that you've used. So I would say it was a hard question, but it was not, it's not that difficult, right? Okay, so let's move on to the next question here. Okay, so let's look at this question here. So this question says that store S has a total of 90 copies that were sold in the last week, and it sold different number of copies on any 2 days. So all the way from Sunday to all the way till we're gonna have Friday, we can have all the days in between, and then we're gonna have Saturday is equal to 90. And the question says that if Saturday is the greatest and Friday is the second greatest, is Friday greater than 11? So that's essentially what the question is asking us. Now let's see if we can solve this. Let's see the statement 1. Statement 1 says that Thursday is actually equal to 8. So if Thursday is equal to 8, that means Sunday plus Monday, I'm just going to ignore the plus sign, Tuesday, Sunday, Monday, Tuesday, Wednesday, Thursday is 8, so I'm just going to ignore that. Friday and Saturday is equal to 90 minus 8, which is 82. So that's what it is, right? Now the question is asking us, is Friday greater than 11? So let's try to maximize Friday. If we try to maximize Friday, then we'll have to minimize all this. So if we want to minimize this, what's the smallest values that they can take? Now why am I doing that? Because I need to know what's the maximum value of f. If the maximum value of f is actually less than 11, then that solves the question. Or if it is greater than 11, then I'll have to probe a little further. So the maximum it can be, the minimum this can be 0, this can be 1, because no two days can have the same number. This can be 2, this can be 3. So Friday plus Saturday is what it is, so that's 82. So Friday plus Saturday is actually going to be equal to 82 minus 1 minus 2 minus 3, so that's 76. So how can I distribute this to make Friday less than 10, 11, and greater than 11? Well, I can make this 10, then this will be 66, that's possible. Or I can make this 12, then this would be 64, that's possible. So I can make Friday less than 11, I can make Friday greater than 11, that means this statement is insufficient. Let's move on to the second statement. So the second statement here says that Saturday is equal to 38. Now let's see how that pans out. Now if I add all the way from Sunday, Monday, Tuesday, Wednesday, Thursday, Friday is equal to 90 minus 38, which is equal to 52. Now the question is Friday greater than 11? Let's just make it 11. So if we make it 11, now why am I doing that? Because I need to test the critical value here. Same thing I could have done there too, but I'm doing it here as well. I mean, in a different way. I can adopt the same approach there too. I can try to find the maximum value, or I can try to find the minimum value, right? But I'm just trying to hit the point here. I'm just saying let's make it 11. But if you make this 11, then what is the maximum you can make Thursday to be? Well, that has to be 10 because you're selling books and they have to be different numbers. This has to be 9, this has to be 8, this has to be 7, and this has to be 6. This is the maximum that it can be. If you actually add these numbers up, you actually get a total of, so this is basically consecutive numbers, so 1, 2, 3, 4, 5, 6. So you take the average, which is right here, 8.5, and multiply that by 1, 2, 3, 4, 5, 6, or you can add the numbers up, whichever way you want to take it. So if I add this up, I get 15 and 8, 23, 43, and then so I get a total of, so basically I can just calculate it. 10 plus, this is 21, 9 plus 7, this is 17, 7 plus 6, this is 13. So this actually comes out to be 51. So the maximum this all can be is 51. If Friday is 11, well, that's not possible. This has to be at least 52. So that means Friday has to be at least 12. So if Friday has to be at least 12, that means Friday has to be greater than 11. That means this statement is sufficient, and B is my answer. So I'm just going to discuss the statement 2 again here. So I made Friday equal to 11. So that is the critical number, just to see what's the maximum this whole can be if Friday is 11. Well, if Friday is 11, then Thursday has to be 10. If Thursday is 10, then Wednesday has to be 9. Tuesday has to be 8. Monday has to be 7. Sunday has to be 6. That's the maximum it can be. It can go lower than that, but that's the maximum it can be. And the maximum was coming out to be 51, which is not possible. So 52 it is. So that means F has to be greater than 11. So that makes the statement sufficient. Okay, so this makes the statement sufficient, guys. Let's move on to the next question. Okay, so let's go ahead and solve this question. Looks a bit intimidating. Let's see here. So this question says that x squared is equal to y plus 5. Then you've got y is equal to z minus 2, and z is equal to 2x. We've got these three equations in three variables, and I'm just going to use the simplest one, and I'm going to substitute in this one here. So then this one becomes y is equal to 2x minus 2. Instead of z, I'm just putting it 2x. Then I'm going to substitute this into this. So then this is going to be x squared is equal to 2x minus 2 plus 5. This gives me x squared minus 2x minus 3 is equal to 0. If I solve this, I get x squared minus 3x minus 1x, 3x plus x minus 3 is equal to 0. So from here I can easily figure out the roots, that x is either equal to 3 or x is either equal to -1. Well, I have these two roots, so I have these two values of x. So from here I can easily say if x is 3, that means z is 6, that means y is 4, or x is -1, then z is -2, and y is -4. So the question is asking us, is this number divisible by 7? Let's just figure it out. So in this particular case, x cubed is 27, z squared is y squared is 16, and z is 6. So that gives me 27 plus 22, so that gives me 49. So that makes it divisible by 7. So in this case is 1 plus 16, which is y squared, plus z, which is minus 2. So that gives me equal to 13, so which is not divisible by 7. So let's now see the question stem, which should be pretty easy exercise. Statement 1 here says x greater than 0. Well, x is greater than 0 only in this case, which will make it divisible by 7, so that is sufficient. Statement 2 here says y has to be equal to 4, which again makes this particular case to be true. That makes it divisible by 7, so that means this statement is also sufficient. Hence D is the answer. That means either of the statement is sufficient to answer the question. So this question looked intimidating, but it wasn't. All you had to do is you just had to substitute the equations one into another and you got the answer. Okay guys, let's move on to the next question. So the answer is D here. So let's move on to the next one. Okay, so let's look at this question here. So this question says that t is a positive integer and r is the remainder when this expression is actually divided by 7. So what exactly is this expression? Let's just try to solve this. So we can see that we got a factors of 2 and 3 here. So this is going to be t squared plus 2t plus 3t. So we can just break this 5t as this plus 6. And then this is going to give us t plus 2, and this is going to give us t plus 3. So that's essentially what this is. And the question is asking us, if this expression is divided by 7, what is the remainder? Well, we do not know whether t is divisible by 7. If we know t is divisible by 7, then the remainder is actually going to be 2 from here and 3 from here. And the remainder of the whole expression is going to be the product of these two numbers. I mean, if you remember the remainders video, so if let's suppose you've got two numbers, some numbers a and b, if they are divided by a number, let's suppose 7, if you get r1 remainder from here and you get r2 remainder from here, then the total remainder is going to be r1 times r2. So this is essentially the remainder theorem. If it's a plus b, then the remainder is r1 plus r2. If it's a minus b, the remainder is r1 minus r2. So that's essentially what remainder theorem is. So let's apply that in statement 1. So statement 1 clearly tells us that t is not divisible by 7, but when you divide t by 7, you actually get a remainder of 6. So that means that you are essentially going to get a remainder of 6 when you divide t by 7. That means you'll be able to get the answer. Now let me show it, and that means this statement is going to be sufficient. Let me just show that to you mathematically here. So this is t plus 2. Always do it mathematically. Never just rely on a hunch or rely on verbal logic here. So t plus 2 and t plus 3 is what the expression is, and t can be written as something of 7 times an integer plus 6. So that's how you can write t to be. And if I substitute this expression here, I'm actually going to get 7 times an integer plus 6 plus 2. So that's actually going to be 8. And 7 times an integer plus 6 plus 3, that's going to be 9. And what I can do is I can actually further break this up. This can be 7 plus 1, and I can further break this up. This can be 7 plus 2. And this 7 can be submerged into the sea of these integers. So basically I can say this number is 7 times an integer, it could be any integer, plus 1, and 7 times an integer plus 2. So essentially what I'm getting here is that this, when you divide this by 7, you get a remainder of 1. When you divide this by 7, you get a remainder of 2. That means your total remainder is actually going to be 2. So that means this statement is sufficient. It actually gives you the answer. Let's move on to the second statement, which is a bit tricky. It says, when t squared is divided by 7, the remainder is 1. Now, I don't want to get into algebra here because I'm dealing with nonlinear equations. So let's just choose some numbers. Let's just start with squares of numbers and see at what numbers you get the remainder as 7. So 2 squared is 4, so that's not divisible by 7. You get a remainder of 4. 3 squared is 9, so when you divide this by 7, you get a remainder of 2. 4 squared is 16. When you divide this by 7, you get a remainder of 2. 5 squared is 25, so when you divide this by 7, you get a remainder of 4. 6 squared is 36. When you divide this by 7, you get a remainder of 1, which means a possible value for t is 6. 7 squared is 49, so when you divide that by 7, you get a remainder of 0. 8 squared is 64. When you divide that by 7, you get a remainder of 1, because 7 times 9 is 63. So that means another possible value for t is 8. So what you can do now is you got two different values for t. You can substitute that into this expression, which is t plus 2 times t plus 3. So when t is equal to 6, the expression is going to be 6 plus 2, 8 times 6 plus 3, 9. So you're going to get 72. And when you substitute this value of t, that's going to be 8 plus 2, which is 10, and 8 plus 3, which is 11. So you're going to get 110. And if you divide these two numbers by 7, you get different remainders. So for instance, here you get a remainder of 2. Here you get a remainder of 5, because 105 is divisible by 7. So you get two different remainders. That means this statement here is insufficient. Hence, only statement 1 is sufficient. So A is the answer. So I hope you got this solution here. So the key to the solution was solving this quadratic equation, remembering the remainder theorem, applying that remainder theorem in statement 1. And then in statement 2, we're dealing with non-linear equations. So let's just plug in numbers and just disprove it. And that was actually disproved. So that means A was the answer. Okay, so let's move on to the next one. Okay, so let's look at this problem here. So this question says that is x positive? So that's a pretty simple problem statement. So the first statement says the absolute of x plus 3 is actually equal to 4x minus 3. So if we try to solve this, it'll actually give us two stems. So the first one is where x plus 3 is actually equal to 4x minus 3, or it's the other way around, where one is the negative of the other. So, or you can say negative x negative 3 is equal to 4x minus 3. So if I solve this equation, I can see that x is 0. If I solve this equation, I can see that x is 2. That's pretty simple to solve. Now, that gives me two values of x, but two possible values of x. What do I have to do is, I have to plug these numbers back in to check whether it's possible. And that's the key to the question. So if you plug these numbers back in, so 2 plus 3, absolute of 5, is actually equal to 8 minus 3, which is 5. So that's possible. But the absolute of 0 plus 3 is actually not equal to 4 into 0 minus 3. Like, absolute of 3 cannot be equal to negative 3. So that means this is implausible. So that means we only have one value of x, hence statement 1 is sufficient. Let's look at the statement 2 here. And again, if we try to solve this, we'll have the same situation where you have x minus 3 being equal to 2x minus 3. So that's 1. Or x minus 3 being equal to negative of 2x minus 3. So x minus 3 is equal to negative 2x plus 3, or you can do it the other way around. So again, if I solve this equation, this one gives me x is 0, and this one gives me x is 2. So again, what do I need to do is I need to plug it back in. And in here, absolute of negative 3 is actually going to turn out to be equal to, negative 3. So, that means I have to, this value works. And the absolute of 2 minus 3, which is negative 1, is actually going to turn out to be equal to absolute of 4 minus 3, which is 1. So that means I get two different values of x. I mean, there was more two values to be tried for. I mean, because there's absolute on both sides. One can be the negative of the other as well. And on both can be negative. I don't need to do that because I got two different values of x, and that itself is sufficient enough to tell me that this statement is not sufficient. Hence, answer option A is the answer. So again, the key to the question to the first statement was that you need to put those values back in. And for the second statement, that was pretty obvious that it's not sufficient because, you got too many different values that could come out for x, and we just proved that, and, that was the end of it. Okay, so the answer was A to this question. Now let's move on to the next one. Okay, so let's go ahead and solve this question now. So this question says, if this inequality is true, whether this absolute value statement is true or not. And there's too much going on in the question stem. So I believe we can, kind of reduce it to a simpler format. So the question says that if zy, so zy is actually less than xy, is actually it's actually less than 0, then the question is asking us whether this inequality is true or not, right? So so whether this particular inequality here is true or not. So I'm going to start with statement 2 here because I think that's the simpler statement out of these two statements. So we can start with statement 2. So statement 2 says y is actually greater than 0. So if y is greater than 0, then what happens to this inequality? It says zy is actually less than xy is actually less than 0. So if that is the case, and if y is a positive number, I can just strike y out and keep the signs the way they are. Because if you strike a positive number out of an inequality from both sides, you don't have to change the signs. So that means that z is actually less than x, which is actually less than 0. Like for instance, z can be something like -3, this can be something like -2. So then what happens to this inequality here? So what happens to absolute of x minus z? Is x minus z a positive number, or is x minus z a negative number? I mean, you can clearly take from this example, x minus z is actually going to turn out to be a positive number. So that means this one here is actually turn out to be a positive number. That means x minus z, when they go out of this absolute value, it just comes out as x minus z, because a positive number comes out as positive. So that is x minus z. And what happens to absolute of z? Well, z is a negative number, so that actually comes out as negative z. Similarly, absolute of x comes out as negative x. And if I plug them back into this particular expression here, the question is asking us, is absolute of x minus z, which is x minus z itself, plus x equal to z? So, sorry, plus absolute of x. So when I talk about plus absolute of x, what's going to turn out? Negative x is going to turn out, is equal to absolute of z. So negative z is going to turn out. So is that true? Well, yes, that's true, because if you actually solve this inequality here, what turns out? If you solve this inequality here, is x minus z minus x equal to minus z. So if you take this x here, that actually becomes positive. So this actually is x minus z equal to x minus z? Well, that's true. So that means when y is positive, this whole thing is true. So that means this statement is sufficient. So that's the case here. Now let's move on to the first statement. So what does the first statement say? The first statement says that z is less than x. Now let's go back to this particular statement here. So that is zy is actually less than xy, which is actually less than 0. Now what implications does it have for this particular inequality? And you know what? We don't even need to deal with this inequality, because z being less than x is actually true here, right? And we're getting the same thing. So if we're getting the same thing, that means even statement 1 is going to be sufficient, because z is going to be less than x only when y is going to be positive. If y is negative, then then this particular inequality does not hold true, because if y is a negative number, and if you cancel this out, that means then this inequality is actually going to turn into positive. This inequality is going to flip the other way. Let me explain that again. So you've got zy less than xy less than 0. So this inequality, if y is a positive number, if you can cancel this out and z will be less than x. But if y is a y is a negative number, then if you cancel negative numbers from both sides, the sign has to flip. So that means what statement 1 is telling me is that y actually is a positive number. I mean, take an example. You can say that 4 into negative 3 is actually greater than 5 into negative 3, right? So negative 12 is actually greater than negative 15. And if you cancel negative 3 on both sides, you would have to flip this sign. And that's essentially what's happening here. So statement 2 is telling you y is greater than 0. If y is greater than 0, then this whole thing is true. And the statement 1 is essentially saying the same thing, that y has to be greater than 0, which means the whole thing is true. We don't have to do the algebra all over again. That means both the statements are sufficient. Hence, answer option D is the answer. So I hope this was helpful, guys. This was a difficult question. So now we'll move on to the next one. So let's look at this question, which says that is x greater than y? So that's what the question is asking us. And statement 1 says square root of x is greater than y. So that's what the statement 1 is telling us. Let's just plug in some numbers to disprove this. So we can plug in some numbers for x. That will give us square root of x. And then we can choose y and check whether x is greater than y or not. So we can plug in x to be 4. Then this is going to be 2. And we can call y to be 1. So in that case, is 4 greater than 1? Yes. Or we can deal with fractions. We can call this 1 by 4, right? Then this will become 1 by 2, right? Now we have to make this greater than this. So we can make this 1 by 3. Is square root of x greater than y? Yes, it is. But is x greater than y? No. So that's insufficient. That means this statement is gone. So we'll move on to the second statement. So I got a yes and I got a no. So that means I was able to disprove this particular statement. So let's move on to statement 2 here. So statement 2 says x cube is greater than y. So again, we can plug in some numbers. We can look for x, we can look for x cube, we can look for y, and we can check whether x is greater than y. So I can plug in x to be 8. That actually gives me x to be 2. Sorry, I can plug in x cubed to be 8. And that would actually give me x to be 2. And what will y be? We can just call y to be 1. So is x cubed greater than y? Yes. Is x greater than y? Yes. So that's sufficient. Then we can plug in x to be 8. We can plug in x cubed to be 8. We can plug in x to be, x will be 2 again. And then we can make this 7. So in that case, is x cubed greater than y? Yes. Is x greater than y? No. So I got a yes and a no. That means this statement is also insufficient. Now is our job to combine both the statements. So our job is now to combine both the statements, and I think we'll have to use algebra here because there's just too many statements to make sure of, too many conditions to fulfill. So I'm just gonna erase the scene here. So this one says, let's combine both the statements. So we've got square root of x greater than y, and we've got x cubed greater than y, right? So that's what we got. So we got x cubed greater than y. Now there are many solutions for this, but I'm gonna try to find a solution that we can solve this under 2 minutes. So from here, what I can see is that, the fractions and non-fractions would be the one which will be making difference. And of course, I know that x has to be a positive number because we're dealing with square root of x, and GMAT doesn't deal with complex numbers. So let's just say, what if x is greater than 1? If x is greater than 1, then I can just turn this inequality easily into x is greater than y squared. I can just square both the sides. Then I can keep this inequality just like this. Or turn this into, square this up, so I can say x to the power 6 is actually greater than y squared. And then I can divide this inequality, number 1, with number 2, just to get rid of the y. So if I divide x to the power 6 by x, I get x to the power 5, right? So that's what I have. I'm able to prove that x to the power 5 is actually greater than 1. Right, which is essentially what I assumed it to be, right? But if x is actually greater than 1, then that means that that means if x is greater than the square of a number, x is actually going to be greater than that number. I mean, that kind of solves it. I mean, I didn't have to do all of that. So if x is greater than 1 and x is greater than square of a number, that means x has to be greater than that number. This may not be a pretty elegant solution to this. However, I think this does the job. What if x is a fraction, that x is actually between 0 and 1? So if that is the case, then what happens? Of course, you cannot assume x to be equal to 0 or x to be, because you have to make sure that these two inequalities are satisfied, right? So what happens when x is actually a fraction? If x is actually a fraction, then you know that x cube is actually greater than y. So in a fraction, you know that when you cube a number, the number actually becomes smaller than itself, right? In this particular case, you have x cube. It's actually going to be greater than x, right? X cube is going to be greater than x. So if x cube is going to be greater than x, that means x is going to be greater than y. Because if cube of a number, which is a smaller number itself, is greater than a number, then the number itself is going to be greater when the numbers are fraction. So that means that in both the cases, I'm going to get x greater than y. Hence, combining both the statements, I get my answer. Let me just reiterate what I just did here slowly. So this is more of a narrative-based explanation rather than using algebra here, right? So this is more of a narrative-based explanation, which I think makes more sense here. So if x is actually greater than 1, in that case, if square root of a number is greater than a number, so the number itself is actually greater than the square root, right? Because if you square root a number greater than 1, the number becomes smaller. So x has to be greater than y. So that makes it sufficient. If x is actually between 0 and 1, then the cube of a number is actually greater than that number, and x lies here. So that means this is greater. So that means x is greater than y. I think that solves it pretty well, right? So in both the cases, I'm getting x greater than y. Hence, it means that combining both the statements, I will get my answer. So I hope this was helpful, guys. And I'm solving this question real time with you. So sometimes I kind of deviate a little bit. So please bear with me on that. So the answer is C. So now we'll move on to the next problem. Okay, so let's look at this question here. This question says that if m and r are two numbers on a number line, what is the value of r? So we want to know the value of r. The first statement says here is the distance between r and 0 is 3 times the distance between m and 0. So if you draw a number line here and 0 is here, the distance between r and 0, how can you express distance on a number line? Well, distance between r and 0 can be expressed something like this, which is absolute of r minus 0. Because if r is here, this can be -3, or let's suppose the distance is 3, or r is here, this can be 3. The distance is always positive, so it's the absolute of difference between r and 0. So that's how you express distance on a number line. It's actually equal to 3 times the distance between m and 0, so which is m minus 0. So from here, I can clearly say either r is equal to 3m, or r is equal to -3m. So I get two different values, right? So clearly not sufficient. Let's look at statement 2. It says that you got m and r on a number line. So let's suppose this could be m or this could be m or r. And then the distance between them is 12, right? So distance between them is 12. Which so not the distance, sorry. 12 is halfway between m and r. So that means if you actually, I'm just going to give you an example here. For instance, if you have two numbers, let's suppose 1 and 3, and 2 is halfway between them, halfway means that 2 is the average of 3 and 1, right? So because you're actually looking at consecutive numbers, the average of consecutive numbers is right in the middle. So that means the average of m and r is actually equal to 12. That means m plus r is actually equal to 24. So clearly insufficient. But when I combine both the statements, I got two equations, two variables, and three possible equations. So I can try to solve this. I can substitute this here first, and then I can substitute this here first. So if I substitute m plus r is equal to 24, and I substitute r is equal to 3m, so I put 3m here, that actually gives me m plus 3m, which is 4m. That actually gives me m to be equal to 6. And the other one, if I substitute negative 3m here, that actually gives me m to be equal to negative 12. And I got a simple linear equation here that will actually give me two different values of r. I can solve it. R would be 18 here, or r would be 36 here. So in both cases, I get two different values of r, which means even combining both the statements, the answer is insufficient. Hence, the answer is option E. So this was not really a difficult question. The only difficulty in this question is translating these statements into mathematical formulations that would actually just solve this question right away. There's no room for plugging into this question. I mean, you can solve this question using plugging in. So you can get two different values of m and r, and you can go with it. But at this stage, I believe this is a better approach to solve this question. Okay, so let's move on to the next one. Okay, so let's look at this question here. So this question says that n over here is a positive integer, and we need to find the value of n. And I'm going to start with statement 2 because that seems like the easiest option to have. So that gives me n squared minus 9n plus 20 is equal to 0. So if I solve this quadratic equation, I get n squared. I can clearly see that the factors are 5 and 4. Plus 20 is equal to 0. So if I solve this, I get n minus 5 times n minus 4 is equal to 0. So that means that gives me that n is either 5 or n is either 4, which is clearly insufficient because I get two different values of n. But this helps me in statement 1. This is going to help me in statement 1. The statement 1 says for every positive integer m, this product is divisible by 16. Now I want to find some kind of constraint for n here, right? I want to see some sort of constraint. I can maximize n to be 1,000,000, then definitely this is going to be divisible by 16 because these are consecutive numbers. Let's try to minimize n. If I want to minimize n, that means I want to minimize m as well, right? Because if I keep m to be equal to 16, then it doesn't really help me. So let's try to minimize the value of n. What's the least that it can be? So in that sense, I will make m to be equal to 1. If I make m to be equal to 1, then we can find the minimum value of n where this is divisible by 16. So that could be 1 times 2, not divisible by 16, times 3, no, times 4, no, times 5, no, because I've got 4 times 2, 8 here. The moment I add a 6 here, this whole thing is divisible by 16. That means the minimum value of n should be 1, 2, 3, 4, 5. That means n has to be at least 5. N cannot go lower than 5. So that means this statement is clearly insufficient because n can have so many numbers. But if I combine both the statements, you can see that this one is gone out, and I know that the value of n is actually equal to 5. That means combining both the statements, I get my answer. So this was a difficult question in the sense that, you start with statement 2, you find out, some numbers for n. Then you go to statement 1, you try to minimize n. You try to find, you can't maximize n because the maximum number of n is basically infinity here, so that doesn't work out well. So you try to minimize n. So if you want to minimize n, that means you want to minimize m. So you start with m to be equal to 1 because it's a positive integer. M cannot be 0. So you say 1 times 2 times 3 times 4 times 5 times 6. That's where you stop because that's where this whole thing is divisible by 16, and you get n to be greater than or equal to 5. And you combine both the statements, the value of n is 5, and the answer is C. So I hope this was helpful, guys. So this would be the end of this video, guys. Thank you very much for watching this video. I am adding more content related to GMAT. I'll be adding the course related to the GMAT focused edition as well. There's more verbal content coming as well. So if you want to access more content, please subscribe and please visit our website to check out all of our content. So thank you very much for watching this video. Please subscribe for more.